Now let us discuss about virtualization or virtual machines. In this video we are going to discuss about what is a virtual machine and system model, a diagram for the virtual machine, how to implement virtual machine, benefits of virtual machines, and two examples. The first example is VMware. Second example is Java virtual machine, that is JVM. First, let's see what is a virtual machine. By using virtual machines, we can execute multiple operating systems in a computer. We have installed 4 operating systems such as Windows operating system, some Linux, Ubuntu, Linux, Fedora, some Macintosh operating system. So in our system we have 4 different computers. So we can use those 4 operating systems in our computer. So now we will be in a feeling that we are making use of 4 computers with 4 operating system. But actually we are using only 1 computer with 4 operating systems. So virtual means it is not real, it is illusion, it is imaginary. So let's see that point. A virtual machine allows users to install multiple operating systems in a computer, thereby making an illusion that each separate execution environment is running its own computer. So here we will be in a feeling that we have different computers. We are working with different computers, but actually we are using a single computer with different operating systems. The major advantage of the virtual machines is we can share the resources of the computer. Let we have 10 resources present in the computer, like it may be some hardware devices like IO devices or some memory or some CPU. So what we can do is we can share all the 10 resources among 4 operating systems. So one operating system can make use of 3 resources, another operating system can make use of another 3 resources, so likewise. So that is the major advantage of the virtual machine. The resources are shared among the operating systems. So for that, here the resources of a computer are shared to each operating system running by the virtual machine. Here users are given their own virtual machines. So Windows has its own virtual machine, Linux has its own virtual machine. So users will be given several virtual machines. They can run any of the OS that are available on the underlying virtual machines. So on Windows virtual machine, we can use Windows operating system. On Linux virtual machine, we can use Linux operating system likewise. So now let's see the system models. So that is the diagram for a non-virtual machine, a virtual machine. If we take the non-virtual machine, on the bottom we have hardware. On top of the hardware we have kernel. So we know about kernel. Kernel is nothing but operating system, the main task of the operating system. Kernel is heart of the operating system. So on top of the kernel we have processors. So these processors are nothing but the programs related to this kernel. So with the help of this operating system, we can execute all these processes. Okay. So the main memory is mainly divided into 2 parts. So the first part is kernel and the second part is processes or programs. We know the difference between a process and a program. Process is a program during execution. If a process is loaded into main memory, if a program is loaded into main memory, it is called as a process. So on top of the kernel, here we have some hardware resources. So this is the diagram. Whereas if you take virtual machine, so at the bottom we have hardware. On top of the hardware we have virtual implementation, virtual machine implementation. So first we have to implement the virtual machine. So for that we need to install a software. So this is nothing but virtual machine software installation, implementation. So on top of it, we have 3 operating systems. So this is operating system 1 virtual machine, VM1. This is OS2 virtual machine, VM2. This is OS3 virtual machine. So we know that users are given their own virtual machines. So here 3 virtual machines are given to the user. And this kernel is belonging to VM1. This kernel is belonging to VM2. This kernel is belonging to VM3. So here these are nothing but the processors of this operating system, processors of the second operating system, processors of the third operating system. So here on top of the virtual machine implementation, we have various virtual machines. Each virtual machine has its own operating system, its own kernel and its own processors. So this is about the system model. Now let's see about how we can implement virtual machine. Okay. Any virtual machine has 2 modes. The first mode is user mode, second mode is kernel mode. So we know that. So we have 2 modes, user mode, kernel mode. So user mode means the corresponding program related instructions will be executed in user mode, whereas kernel mode means operating system code, some privileged instructions, important instructions are executed in kernel mode. So kernel mode in kernel mode mainly operating system related instructions are to be executed. So next point, the virtual machine software can run in kernel mode since it is operating system. So here this is nothing but virtual machine software. So this software can be run in kernel mode. Why? Because that is virtual machine software. It is an operating system. So that's why it should be run in kernel mode. So next point, the virtual machine itself can execute only in the user mode. Here virtual machine means here we have 3 virtual machines. So VM1, VM2, VM3. These 3 virtual machines will run only in the user mode. Whereas this virtual machine software, it will be run in kernel mode. So next point, when a system call is made by the program, when a system call is made by the program running on a virtual machine in virtual user mode, then it will cause transfer to the virtual kernel mode. So if we execute a system call in virtual user mode, then what will happen? Our control will be transferred to the kernel mode. Why? Because system call means it is a privileged instruction. It is an operating system. So for executing that instruction, operating system service is needed. So what will happen? When a system call is executed in virtual mode, then automatically the control will be transferred to the virtual kernel mode. Real I/O might have taken 100 milliseconds, whereas the virtual I/O might take less or more time. Okay, so it depends. So this is about what is a virtual machine, system model and implementation. Now let's see about benefits of the virtual machine as well as examples. Now let's see the benefits of the virtual machines. Let's see the first benefit. Virtual machine provides high degree of protection to various resources of the system. Let we have 3 operating systems. OS1 has 3 resources, OS2 has 3 resources, likewise OS3 has 3 resources. Here OS1 can use only its resources. OS1 cannot access OS2, OS3 resources. So we have high degree of protection to our resources. Because if any of the operating system corrupted or malfunctioned, leads to effect only on the relevant virtual machine. Suppose if there is a problem with one operating system virtual machine, then we will get then we have problem only on that virtual machine. We can make use of remaining 2 virtual machines very comfortably. There is no problem. So if there is a problem with one virtual machine, then it doesn't lead to problem on the other virtual machines. Next, another advantage, other users of the virtual machine can continue their operations without being disturbed. So if one virtual machine failed, then there is no problem on other virtual machines. Other users can do their work very easily without being any disturbance. Various operating systems can be run concurrently to solve the needs of various users. So here we have 4 operating systems. So now all the 4 operating systems can work simultaneously, can work concurrently in order to solve the problems of the users. Another advantage is easy maintenance, availability and convenient recovery. So these are the various benefits of the virtual machines. Next, we have 2 examples on the virtual machines. The first example is VMware Architecture. So first let's see this one. Next, we will see the second example, that is JVM. JVM stands for Java Virtual Machine. So this is the diagram for the VMware Architecture. At the bottom we have hardware like CPU, memory, IO devices. On top of it we have host operating system, that is Linux operating system. So in our diagram the host operating system is Linux. On top of it we have virtualization layer. So it acts as an interface between host operating system and guest operating system. Here we have 3 guest operating systems such as FreeBSD, which is an operating system, Windows NT, Windows XP. So these 3 are guest operating systems, whereas Linux is host operating systems. So these are nothing but applications of this operating system, applications of this operating system, applications of this operating system. Now let's see an example. Let's see the theory about the VMware architecture. VMware runs as an application on the host operating system such as Windows or Linux and allows this host system to concurrently run different guest operating systems as independent virtual machines. So here what is VMware? We can execute VMware as an application on host operating system. It may be either Windows or Linux, but in our example the host operating system is Linux. Now host operating system can work concurrently with guest operating systems. Consider a scenario: a developer has designed an application and would like to test it on Linux, FreeBSD, Windows NT and Windows XP. So here what is our target? We have an application and we have to run that application on all the 4 operating systems, host operating system as well as 3 guest operating systems. So here we have 2 options. One option is to obtain 4 different computers, each running a copy of these operating systems. So what is one option? We will have 4 different computers where we need to install Linux on one computer, Windows FreeBSD on one computer, Windows NT on one computer, Windows XP on another computer, and that application will be executed on all the computers. So we require 4 we require 4 computers where one operating system is installed on every computer. Whereas another option is to test the application on host operating system. So we have to test that application on host operating system and on 3 guest operating systems, with each system running as a separate virtual machine. So this is one virtual machine, this is second virtual machine, this is another virtual machine. So here the application will be executed on the host operating system and the same application will be executed on the 3 operating systems with 3 virtual machines. So which is the best approach? The second approach is the best approach. Why? Because we have only one operating system, we have only one computer with 4 different operating systems. So the same application can be executed on all the applications. So this is about VMware architecture. Now let's see the second example, that is JVM, Java Virtual Machine. Now let us discuss about Java Virtual Machine. In short, we can call it as JVM. We know that Java is the most popular object-oriented programming language which is invented by Sun Microsystems in 1995, but currently Oracle Corporation owns Java programming language. Here mainly we have a software called JDK. JDK stands for Java Development Kit. JDK provides an environment to develop Java applications. JDK contains several tools such as JRE, and it contains several tools like Java-C, Java compiler, and Java, a debugger. So that is about what is JDK. Let's see about JRE. JRE stands for Java Runtime Environment, which provides an environment in order to run our Java applications. JRE mainly contains JVM. So in this, now we are focusing on JVM. JRE mainly contains JVM. JVM means Java Virtual Machine. We know that a Java program is a collection of classes. So we know about what is a compiler. Compiler compiles the source program. Compiler translates source code into the bytecode. Bytecode means the extension is .class file. So if our program contains 5 classes, then the Java compiler will produces 5 class files. But we have to execute the main class. So that means the main method which is present in the class. So that is called as main class. So even if we have 5 classes, we need to execute only the main class. So here the point is JVM mainly contains 2 things, class loader and Java interpreter. Class loader loads that main class into the JVM for execution, because that main class file is needed for the execution. So JVM mainly contains class loader and Java interpreter. So what is the responsibility of the class loader? It loads our main class into the JVM that is needed during the runtime or execution. Next, we know that the task of JVM is it executes the Java program line by line, but that is possible internally with the help of Java interpreter. Interpreter executes the bytecode line by line. Next, here we have a compiler called JIT compiler, JIT. JIT compiler stands for Just In Time Compiler. Here JIT compiler works along with JVM in order to improve the performance of our Java programs. So here we have this part is nothing but JVM. JVM mainly contains class loader and Java interpreter. Here we have a host system. So we may have Windows operating system or Linux operating system in our computer. Here we know that Java is platform independent language. So what is Java? Java is platform independent language. Why? Because if we run Java on one operating system, then the same program can be executed on any operating system, on the other operating systems also. Whereas JVM is platform dependent. So what is JVM? JVM is platform dependent. Why? Because here we know that the compiler will produces the bytecode. The compiler will produces bytecode. Bytecode means the extension is that .class file. Here the same bytecode can be executed on Windows operating system or Linux operating system or Mac operating system, Apple, Mac operating system. So here Windows operating system has its own JVM, Windows JVM. Windows JVM, it executes the corresponding bytecode. Likewise, Linux operating system has its own JVM, Linux JVM. It executes the corresponding bytecode. Next we have, let us take Mac operating system. So Mac operating system has its own JVM. It executes the corresponding bytecode. So here the point is, JVM is platform dependent. Each operating system has its own JVM. So if we are using Linux operating system, then Linux has its own JVM. If we are using Windows operating system, it has its own JVM. So Windows JVM translates our bytecode into the mission code and executes the program. So likewise, Mac operating system, Mac JVM, translates the bytecode into the mission code and executes the program. So that is about what is JVM. Next here we have Java program class files. So we know that this class loader loads the class into the JVM. It is the responsibility of the class loader to load the main class into the JVM for its execution. So for that, the class loader will take the class from the Java program. Next here we have Java API class files. So we know about Java API. API stands for Application Programming Interface. Java API is a collection of classes. Here we have a class called Scanner class. This is very important class. So with the help of Java API classes, we can do input operations, output operations. If we want to work with some GUI components or AWT components, we can work with all those components with the help of this Java API classes. So let's say 2 to 3 classes. We have a class called Scanner class. If we want to use Scanner class, then we must import util package. Why? Because Scanner class is available in util package. So likewise we have string buffer class, and we have string class. So if you want to make use of string buffer class or string class, then we must import lang package. Why? Because these two are available in lang package. So this is about Java API. So API means a collection of classes. So here this class loader makes, for developing the program, we have to make use of the Java API classes. So this is about JVM or Java Virtual Machine.